Hello and welcome to my new video. As you can easily see behind me, I have an old acquaintance lying here on the table, and that's the Sunbooster vertical. I've already introduced this photovoltaic fence system to you in 2 videos. But many of you complained that I never had the system live here with me, and therefore couldn't carry out a proper test. We're just going to fix that right here now. I had the manufacturer send me the system here. Important, this system here comes directly from the trade show, so it has already been used. So please forgive me if there are already a few scratches on the system. Nevertheless, we can still test the system here and take a closer look at it. First, I want to quickly address questions from previous videos. For that, let's take a quick look at the manufacturer's website. Here you can see the system in front of you, and that brings us to the first question. In what lengths is the system available? Let's just click here, in 2 meter and 2.5 meter long strips. It's also important to mention that we can buy the system here as a single system, double system, 4 system, or just the 6 strips. There were frequent questions about the performance values. Here it is with the single system, 6 strips, 468 watt peak. The same goes for the other systems. I don't need to read everything aloud. You can also see it here. Here are the key technical data for the devices. These were also frequently requested. Here you can see them, and importantly, you can also find them, and that's important. Everything I'm saying is also on the manufacturer's website. The link is in the video description below. What might also be important for you are these values here. Direct current input and alternating current output are clear, just like any balcony power plant, as are the protection class and other details. Then, of course, it would also be interesting to know how can we set up the system. As you can see, the system can consist of either 1 panel, 2 panels, or several combined panels accordingly. Here we have our inverter. One fence panel is basically connected to one side of the inverter and the other fence panel to the other side. Connect a single panel as shown. Personally, I'm also curious, what does one row provide? We have a 2.5 meter strip with 79 watts and a 2 meter strip with 62 watts. Then an important point in the comments which keeps coming up was the high price. Here, I want to note that vertical is currently the most affordable photovoltaic fence system on the market, considering these points. Important. The system is easy to install without specialized companies. We don't need any storm anchors, foundation reinforcements, or other protection systems here, because we have larger photovoltaic systems or corresponding photovoltaic modules that we then attach directly to the fence. Such a high load or such high pressure on the foundation that it could usually be torn out during the storms we currently have here. Of course, it's also important to consider the costs in relation to or compared to the amortization costs. I'd like to show you a small example of this here. You can basically do this yourself as well. Just calculate it here with the amortization calculator or time calculator. That means we have the length of the fence here. I'll just put 2 meters for myself here. That's a tiny little fence. What's the panel orientation? For me, it's east-west, which I'll demonstrate. But we can also choose north-south. Then we're here in Germany. That means we select that. Currently, it doesn't include the 19% value-added tax. Is there a subsidy? I don't have one here. You'll need to check your own situation, as some countries or cities may subsidize this. And we enter the electricity price. For me, it's currently around 37 to 42 cents, so I'll just enter 40 cents per kilowatt here. Now we can see the output values here. That means if we use the electricity at 100%, we would have an amortization period of 2.7 years. It should also be mentioned that not all of you will use the electricity at 100%. Here, we could then increase the time a bit accordingly, but that depends on your usage. I want to add that a 2 meter fence gives off so little energy. I assume, at least at my home, that I would really use the electricity here 100%. In my house, I always have a base load of at least 350 watts. That means I would use the energy 100%. For me, this calculation means I could have paid off the fence in about 2.5 to 3 years, no problem. You can share your opinion in the comments or calculate your own situation here. Enough about the technical data, let's discuss the product. I have the individual strips here and have bent a meter like this. There you can see a strip like that. Mine is 2 meters long. That means we chose the short strips. These strips can now be easily threaded into an existing fence. The problem here, unfortunately, is the following. I don't have a place to install this fence, but I would still like to test the fence to some extent. Let me show you the options I have here. I could use this installation location. This one is rather unsuitable because it's completely on the north side and entirely surrounded by buildings. That means we never have sun here, and it's completely shaded and also completely overgrown. I can't trim the shrub and bush because they belong to my mother, not me. If I cut that down, chaos would erupt. That's why I came up with something here. I've got a little construction site here, quickly went to the hardware store and just bought a double rod fence or a fence panel like this. The downside is this panel has only 4 sections, so we can only insert 4 strips. Nevertheless, I'm just going to set this up here temporarily in one spot. You can see I've secured it here a bit with tension straps so it can't fly away. And let's just take a look at this installation situation before we start with the installation. How is the system set up? Basically, the strips have 2 sides. So let's take a closer look at this here. You see, we have a label plus on the strips here, and of course minus on the other side. It's important that when you insert the strips, plus is on one side and minus is on the other side. Otherwise, you'll have problems with the connections, or to put it another way, it won't work. Then we have a primary strip. I'll just call it that for now. Let me get it out. That would be this strip. I'll always install this in the lowest position. Here we have the 2 terminals for positive and negative, which will ultimately be connected to the inverter. Of course, you can also extend these if needed. And of course, this one has to be inserted at the bottom first for the main connection. And at the top, the other strips are simply attached here with these quick connect connectors. Then we come to threading our strips. Basically, it's quite easy to do. The strips themselves, as I said, have positive and negative. And we start at the bottom side with the starting strip. That's the one with the 2 multi-contact 4 connectors. We thread the strips in here. Which pattern you use here is up to you, and we work our way up like this. I'll just insert the other strips here now. It's important to note when you reach the top, the last strip is a finishing strip. You can recognize it here by these finishing ends. We'll also thread this one in up here now, and we can simply connect the strips to each other on both the left and right sides. These have these quick connectors here. Make sure that these quick connectors have a gasket inside. Of course, this gasket should be in the correct position, and these quick connectors also have a little notch here. Of course, this needs to be in the correct position. Connecting and properly screwing in these 2 contacts makes them waterproof. Now, let's discuss the inverter. I've temporarily attached it to the fence for testing. Attach the inverter near the fence, but not directly on the ground. Secure it a bit higher. Of course, you can also install it in a protected place and then simply extend your photovoltaic cables to the inverter accordingly. You can do that however you want. We have 2 connections here. One is the negative pole, which we can plug in here, and the positive pole, which we simply extend through. That means I plug this together here and connect it on the other side with this extension cable. We can attach the extension cable to the fence or lay it on the ground here, whichever you prefer. So at this point, just to address a few questions in advance. We've set up 4 strips here now. You can fit up to 6 strips in one string. How much voltage do these 4 strips have? You can see right now it's cloudy at times and sometimes a bit sunny. We'll measure the voltage here now, and with 4 strips per roundabout, I'm getting about 28 to 30 volts. That's the output voltage here. And with that, we're exactly in the voltage range that can be handled by the inverter here without any problems. So now we can reconnect this here and connect the inverter to the power grid. The inverter includes a 230 volt IP certified power cable as shown here. We can now click this together like this, have it connected and plug the other side into the socket. We have a 10-meter cable, which should be enough for most installations. As you can see, the fence is now ready for operation. We're now waiting for the inverter to connect to the grid. You can see that from the status LED. As long as it's blinking yellow here, the inverter is still connecting to the grid. And when it lights up or blinks green, the inverter is in operation. Now let's move on to the data. As you can see, the weather right now is anything but good. It's even starting to drizzle a little. Let me take a quick look at the sky with you. This is what it looks like right now. And it's also important to mention that it's almost noon now, which means the sun is exactly here and the fence is oriented east-west. Now, with this cloud cover, we're generating somewhere between 35 and 130 watts. I actually think that's pretty good for this situation. But what the fence really delivers, we'll just take a look at over the next 1 or 2 days. And we're hoping that maybe the weather will get a little better too. So at this point, a little time jump. Some time has passed. I installed the system on Tuesday around noon, and now it's Thursday also around noon. That means we've let some time pass and have been able to collect some data accordingly. The weather, well, what can I say about it? Overall, it actually let us down. It rained, it was cloudy, and there were also a few sunny spells throughout the whole thing. Unfortunately, not very many, as I said. We installed the system here with 4 strips. I want to emphasize this again. The manufacturer states that, if possible, you should install 6 strips per fence panel accordingly. I only installed 4. An important point, the fewer strips you install, the lower the tension of the system. And from a certain number of strips, the tension of the system is so low that the inverter might have problems accordingly and then might occasionally shut down because the inverter needs a minimum voltage of 24 volts. Just mentioning that, that's why I recommend you install 6 strips if possible. Unfortunately, it wasn't technically possible for me. I only had space for 4 strips. I've installed 4 strips here. The manufacturer states that each strip has around 62 watts peak. Important. These figures refer to an optimal alignment of the strip. That means if the sun is shining like this, the photovoltaic module, I'll show it carefully, would have to be aligned like this. We have a fence installation, which is of course vertical, so we automatically have losses. You can Google this yourself. Such losses are common. Around 20 to 30%. That's actually realistic. We can test that right here. I have an existing system here, which is basically installed in the same spot. Here we have 2 modules installed, around 800 watts. And let's take a quick look at the app. The sun is shining perfectly on the module or on the modules, and we're drawing about 560 watts. You can figure that out yourself. That's exactly 70%. So we know that this 30% figure is correct. Now, as I said, we've installed our 4 modules here. That would mean a peak output of 243 watts with optimal alignment. I've done a bit of testing here now. When the sun is really shining well on the system, I can generate around 170 to almost 200 watts at peak here. That would be more than the manufacturer promises because, as I said, we've installed 248 watts peak. You have to subtract 30% due to the structural conditions. That means mathematically the system should generate 170 to 175 watts. And we've met that here without any problems, despite the shading caused by the corresponding double rod fence panels, meaning the rods in these panels. That was a key criticism from my viewers in recent videos. What about the shading? We've answered that here. It's basically not relevant and has almost no effect on these systems. I'd just like to show you how well the system handles shading the next morning. Here we have a situation. The sun, yes, it rises pretty early here, but until about 9 o'clock, it's not present at this spot because I'm shaded by buildings here. And here we see the fence standing, and it is, yes. What would you say about the fact that more than 2/3 of it is in the shade? My modules, the standard ones I've installed here, if I shade 2/3 of them, they produce exactly 0. And here with these modules, let's take a look at the app. We have something around 20 to 25 watts of output, despite this massive shading of the modules. That means these modules, these strips, handle shading excellently and can still generate energy even under heavy shading. You can see it here. The module is really more than 50%, almost 70% shaded, and we still have a bit over 20 watts of output. Let's move on to the operation. Let's just take the situation as an example. An hour later, around 10 o'clock, the sun is still not perfectly aligned. Let's just take a look at the fence here. This is what the fence looks like, and the sun isn't shining on the fence optimally. It's still a bit cloudy. Nevertheless, we're easily generating well over 170 watts here with these 4 strips. So that's 100% fulfilled, just as the manufacturer promised. Let's review the statistics again. As we've collected plenty of data, the weather was poor, but nevertheless, let's just take a look at the app. As you can see here in my app, I've included the current time up there for you. I'll show it to you over here. As I said, right over here, it's 12:16, so around noon. That means the modules aren't actually performing well right now. Illuminated, I'll show it on my smartphone. That would be the module. So that's basically how it stands here. And back here would be the sun shining down from above. That would be it, basically. We would have illuminated this side, but nothing would be optimal. You can see on the screen there, we have 139 watts, which is the highest for this situation. Let's take a look at today's production. I'll click it open. As I said, you can see here that the shading at my place is extremely strong until about 8 or 9 o'clock. The clouds remained, and then the system gradually started producing. And now we can basically see here. Here we've chosen the east side as the primary generation side, and on average we've been able to generate around 160, 170 watts without any problems. That would be exactly what the manufacturer promises us as well. We maintained that well, except during total cloud cover and brief rain showers. You can see that here in the data. What did it look like yesterday? Let's go back a day. It looks similar. Early in the morning, it was the same again. Here, it's a bit of a sad sight because we're completely damaged, and then, yeah, a bit of bad weather. And here, of course, at the peak, we also had some nice spikes with 191 watts. And here, we even got close to 200 watts. That would be much more than the manufacturer promised, which we generated here on the west side. By midday, as I mentioned, it's a bad position since the sun is at the wrong angle to the modules. Then it recovered a bit again, and then of course everything clouded over. Some thunderstorms and rain showers passed through here, and accordingly the production was more than modest toward the evening, but the modules aren't to blame for that. It was simply the weather. I can also show you the current images here. This is what the weather looks like here for us right now. On the day of installation, you can see we started up the system here at 12 o'clock, roughly, or at least the inverter installed the app, and then it just kept running like that. We had a few smaller peaks here where there was a bit more, and then the weather let us down again in a big way. Nevertheless, you can see here in the data, the values promised by the manufacturer are definitely being reached. We can generate electricity with the modules throughout the day, morning, noon, and evening. I would say that the main side, the front side, delivers the best generation. That means you should install the strips so that they face where the sun is most visible. For me, that's the east side. The west or back side of the modules generates less than the main side, but as you've seen, it still works. Unfortunately, I couldn't test it here because we've always had terrible weather in the afternoons. So that should pretty much wrap up this short test. I also want to point that out again. I only installed 4 strips, but the manufacturer recommends 6 strips. The system delivered the values that the manufacturer promised, and in some cases even exceeded them. You can also let me know your opinion about this in the comments below. Very important, I want to point out once again that this system can be installed by anyone on their own fence. We don't need to reinforce the foundation. We don't need a professional company for the installation. We don't need an electrician for the installation, and we can run it as a balcony power plant. Because often, or how should I put it, in the last videos, people often commented, yeah, I'll just slap a few heavy bifacial glass modules onto my fence. I have the same thing, but for much less. However, here's an important warning. I've already seen several fences here in the region where people have tried that. They just hung the heavy glass modules on them. The heavy glass modules are really heavy by themselves. They're completely windproof. Meanwhile, the strips I showed have slits. Here, the wind can still pass through, reducing wind load, but the large, heavy glass modules remain affected. On your fence, that's usually too much for most fences because the fences are only designed to handle their own weight. And if I attach a glass module with heavy aluminum holders, screws, and the wind pushes against it, as a result, after a storm, your fence might have been standing like this, and after the storm, it's standing like that. That would be the end result if you don't deal with the statics of the system. This system lets you set it up easily yourself with no installation or wind issues. And in terms of price, the system is similar to when you screw on your corresponding glass modules. But as I said, you don't face all these risks. If you're interested in the vertical, in the Sunbooster vertical, just take a look down in the video description. I'll link the system and the calculator for you. This way, you can calculate everything for your situation, including the amortization. And if the manufacturer gives me a corresponding discount code, I'll also add it for you down in the video description. That way, you can also get a discount when purchasing these systems. So that's pretty much it for this video. If you have any questions or comments about the system, just write them in the comments below. This way, I can reply to your comments below or make a follow-up video. If you enjoyed or found my video helpful, please give it a thumbs up. Want to watch more of my videos? No problem. Just subscribe to my channel here. It's free on YouTube. I'll say goodbye. See you next time. Your Mark on YouTube.